Okay, so in this video, we're trying to find the intersection of these two equations. And I feel like even before you approach this problem, you should always try and graph it to see if and how they actually meet with each other. Even if from the graph you can't tell what's happening. So I'm going to use Grapher, right? This is a simple program, and there are many like it. And what we're going to do is just enter in these equations to see how they interact with each other, right? Do they actually meet, and where? So our first equation, I think, was x minus 2, right? And that was squared. And then we had plus y squared, and that equals, 1. So there's our first equation. That's a circle. And you can kind of tell from the formula that it is, of course. And our next equation, here we have a line. It's a linear equation. I can tell because there are no exponents on the variable. It's greater than 1. And we have x equals 5 minus y. And here you see, I think, that this circle and line just don't meet, right? And that's obvious from the graph. So you could say, okay, they don't meet. But what will tell us, and at what point will we realize that they don't meet if we are not graphing? In other words, if we're just using the algebra. So let's look at that. So the first thing you might do is somehow substitute or plug in these values so we can solve. And I notice right away we're told in this equation that x is equal to 5 minus y. So what we can do is, in our first equation, when you see x minus 2, we can plug this in, right? So that we only have one variable to work with. And that's a much nicer thing to have. So here we have x minus 2, but I'm going to write 5 minus y minus 2, because that's just like x minus 2. We're squaring that, plus y squared, and that equals 1. So here we want to simplify a little bit. We have 5 and minus 2, that's 3. So now we have 3 minus y, we're squaring that, plus y squared equals 1. So now when we expand this, we get 3 minus y, right, times 3 minus y, that's 3y minus y squared, plus y squared equals 1. Use the distributive property, we have 9 minus 3y and minus 3y, it's minus 6y, plus y squared from here equals 1. Now if we simplify it, I would subtract 1 from both sides, right, and combine like terms, and now we have an equation to work with. 1 minus 1 is 0, 9 minus 1 is 8. I'll put it over here though to keep it in a standard form. Y squared plus y squared is 2y squared, right, and then we have minus 6y, right, plus 8 equals 0. So now we have to ask ourselves, well, what factors of 8, right? Positive 8 add up to negative 6, and then we can solve it that way, but I'm going to factor out 2 because I notice that all these numbers are a multiple of 2. So factoring that out, we get 2 times y squared minus 3y plus 4 equals 0. Now to factor this thing right here, of course, I would first of all divide both sides by 2. That would get rid of this 2 right here because 0 divided by 2 is just 0. And now we're only dealing really with this right here. So what factors of positive 4 add up to negative 3, right? How do we do that? Well, what are the factors of positive 4? Well, we have 4 and 1, right, and 2 and 2, and also negative 4 and negative 1 and negative 2 and negative 2. And notice that none of these add up to negative 3. So we might want to use the quadratic formula here, right? We know that x is, or in this case, y is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. And we can go through this and solve for y. But when you're encountering this type of situation, before you really plug in here, I always try and evaluate my discriminant, which is this part of the equation right here. Because we're taking the square root of the discriminant, if this discriminant, this term, which is b squared minus 4ac, is equal to 0, then we only have one solution because negative b plus or minus 0 won't change anything, right? If it's positive, we could have two solutions because adding or subtracting a positive value could change your answer. But what about if this is less than 0? Well, in that case, we're taking the square root of something less than 0 and doesn't have any real solutions. So we should test to see, is this thing less than 0? Because if it doesn't give us any real solutions, that tells me that does not intersect. So here, if the discriminant is less than 0, we know these two equations right here don't have a real solution. In other words, they don't meet each other. So let's figure that out. B is equal to what? Well, that's negative 3. So b squared is negative 3 squared, which is 9, minus 4 times a is 1, times c, which is 4. And there you can see it, right? 4 times 1 times 4 is 16, so we have 9 minus 16. And that's equal to what? Well, that's negative 7, right? And here our discriminant is negative. That tells us we don't actually have a solution, any real solution. In other words, there's no real point where these things meet. And you can see it right here. They don't meet with any real numbers. All right, hope that helped.